channel metadata. Then T0 can allocate a channel. So the channel is just just a virtual address. Then it can allocate 2 threads and transfer the channel, the ownership of the channel to PT thread, and transfer the consumer right to CT. So we can see all virtual memory, all SPMC virtual memory of consumer and the producer are mapped to the same physical memory. After that, the producer and consumer can directly communicate. And we also use the metadata to record the offset of each producer and the consumer. So this figure shows the details of the channels. Atop the channels and the original 16 cores, we provide a subset of MPI functions like burial and broadcast, scatter, and so on. For these collective communications, we have to explicitly specify channels to be used in implementation of each function. Here is a simple example of scatter. And we can see above, here is our interface. We have to specify the channels. Next, I will introduce the evaluation, our preliminary result. This is the current extended determinator, supports 32-bit x86 architecture, 4 kilobyte page size, and limited in 1 gigabyte physical memory. And the evaluation environment is 48 core. Here we also use DET-SM to represent the original determinator, and DET-MP is the deterministic message passing we developed in this paper, and Linux MPI. The first benchmark is matrix multiplication. We compared deterministic message passing with original ones. And the result shows that MP scales better than DET-SM and achieves close to ideal scalability. Because merging in DET-SM occupies more time percentage than communication in DET-MP. Another benchmark is integer sort. We compare deterministic message passing with original Linux MPI implementation. The speed up of DET-MP is lower than that of Linux MPI on 4 and 8 CPUs, but it still scales very well, and unlike Linux, guarantees determinism. So, to conclude our work, SPMC model offers a virtual memory foundation for implementing scalable, deterministic, and conventional parallel programming models. Our future work is to explore more efficient SPMC region implementations and support more scalable programming models and I/O capabilities upon SPMC. Thank you.
Questions? No questions from the audience? Come on, guys.
I didn't follow the presentation very well. At the end, you use the deterministic MP. So we use the SPMC to support that.
We first develop the SPMC region at kernel level. Then, atop SPMC region, we develop a deterministic message passing.
Yeah. So my question is, there are other ways to implement the deterministic message passing. So, for example, I have MPI applications. I can use other ways to implement that. So, how do you compare these two approaches?
The first thing is, if you use other way to develop deterministic message passing, what kinds of foundation does another deterministic message passing use? One thing is you have to use the existing Linux and other things, but the Linux cannot guarantee determinism. So in our solution, we first we use the determinator. It is a deterministic operating system, but determinator has limitation. So one work is how to provide scalability of determinator. So this paper, the contribution of this paper focuses on how to increase the scalability and how to provide more deterministic parallel programming models. Thank you.
I really liked the talk, and I was wondering out of curiosity, perhaps you have it in the paper, if you have compared your system with one that doesn't provide deterministic replay. Of course, you expect that you pay a cost for determinism. I was wondering if you have an idea how much that cost would be.
That as repeated.
So, comparing your system with one that doesn't have deterministic replay, but provides NPI.
The two benchmark, the second benchmark IS, we compare the deterministic message passing with the existing non-deterministic Linux plus NPI. Yeah. Thank you so much.
So there are currently some hardware support to implement scalable and efficient deterministic operating system software. What kind of hardware modifications would be beneficial to your system?
I think so. I think because the core part to support determinism in determinator, I think, is the workspace consistency. But it takes a copy on write policy because workspace because we have to separate the workspace of each process, and it costs a lot of it takes a lot of cost. So I think if some hardware can provide such as copy on write and separate devices, separate workspace, maybe it is very helpful. Thank you.